Welcome. Today we're going to be talking about a couple of ideas that are important for the introduction to a science course, and they pop up from time to time, and it's just something that recurs throughout the year. So usually it's important to go over these at least briefly at the beginning of a year so you will know what they mean when they come up and what these ideas are. Both of these ideas have to do with taking data and what we mean when we're describing the data that has been taken. So the first thing we need to talk about is the definition of accuracy, and that has to do with how close a measurement is, or a collection of measurements are, to the true value of whatever it is we're trying to work with. So if you look at these two golf balls, you've got one in the background, one in the foreground. Which one do you think, by analogy, would be a more accurate measurement as compared to the true value, which is represented by the golf ball hole over here? And the answer is the one in the foreground, right? So that's going to be closer to the true value. It's essentially more accurate, we would say. This is less accurate over here. That's kind of what we mean by accuracy. I'm going to be giving you some examples later on so you can more clearly see what this would look like in a data table. But I do want to give you an analogy to begin with to kind of get the idea as we move forward. And another idea that we need to talk about is what's called precision. So precision really has two different meanings in science courses. So the number one meaning usually is what this number one is up here. It's how precise the measuring devices are. So if you look at these two rulers right here, this top one and this bottom one, my question to you is, which ruler, the top or the bottom, do you think is more precise? And the answer is the bottom, of course. It's more precise because it has finer gradations. You can make more accurate measurements based on the measuring device itself. So precision does have to do with how accurate the measuring devices are that are being used. Another meaning of the concept of precision has to do with how tight a collection of data points are. If they're scattershot all over the place, we would say those data points are not very precise. But if they zero in and hone in on a central point, then we would say that they are more precise. So let's go over some conceptual examples, and then we'll do real-world examples after that. I want you to take a look at these four examples right here. So these are conceptual examples again. I want you to think to yourself, all right, if we have these four scenarios, imagine you're playing darts, and we can label these four scenarios. So the first one is accurate and not precise. It's accurate because it's centered around the true value. The true value is going to be represented by the center of the dartboard right there. The second example over here is going to be considered to be accurate and precise. And this makes relative sense. If we compare these two, we can see that the darts are closer together. The data points are more closely clustered together. And so that's the second definition of what we mean by the term precision. So we could say this is both accurate and precise. If we look at this example over here, this is precise because the data points are closely clustered around a central point right here, but they're not accurate. Relatively speaking, they are not accurate if you compare them to like this or this up here. These are centered around the center of the dartboard over here on the right, and these are centered around the center of the dartboard on the left. So we would say these two are accurate in a way that this is not, because the center of these data points is off to the side. This is not accurate in the sense that it's not centered around the center of the dartboard. All right, and lastly, we have not precise and not accurate. This is where you have a scatter shot, meaning it's just not precise. It's all over the place, not accurate in the sense that it's not centered around the true value that you're looking for. All right, what I would like you to do is to try them. I've mixed them up, and I want you to think to yourself, what are these four examples now in terms of precision and accuracy? Take a moment to do the first one really quickly. The question is that accurate and is it precise? Okay, the answer is this is precise. You have a tight cluster of data points, but it's not accurate. It's not centered around the central point, the true value for whatever it is that we're measuring. How about this one on the right-hand side? I want you to think, is this accurate and is it precise? The answer is this is accurate, it's just not precise. You have kind of a scatter shot. If you compare these values compared to these values over here, they're more scattershot. They're more spread out all over the place. How about this bottom left example over here? Is this accurate and is this precise? The answer is yes, it's both accurate and precise. Over here, you have a tight cluster of data points, so that means it's going to be precise, and it's accurate because they center around the center point here representing the true value of whatever it is we're measuring. How about this last one? Is this accurate and is it precise? The answer is no, these are not accurate nor precise. They're kind of spread out all over, scattershot, and they're also not centered around the true value, which is represented by the center of the dartboard. And there's our answer right there. So let's try this in one more way when we look at some actual data. But first I need to talk you through an example I created. So it says the teacher gives his class an introductory measurement activity and has the 3 groups of students measure the same event. How long a soccer ball is in the air before it hits the ground after being dropped from 8 feet high. What feedback should the teacher give to each group as the group in terms of being accurate or not accurate and precise or not precise? Alright, so the true value of how long it'll take this ball to hit the ground would be 0.707 seconds. It turns out that this is hard to do. It's hard to get accurate time if you're just holding on to a timer or using a cell phone as a timer. And so let's say there are 3 groups that we're looking at. Each group has 4 people in a group, and these are their data as we look at them. So I want you to start thinking yourself, Group A, compare with Group B, and compare with Group C. And I want you to start thinking in terms of accuracy and precision. What can we say is true about Group A? Is it accurate? Their data right over here. And is it precise? Remember, the true value is 0.707 seconds. Okay, well, if you look at this data over here and you compare it to some others to see what's going on, you could say, first of all, this data set is not accurate, and it's also not precise. It's not accurate because it's not centered around the true value of 0.707 seconds, and it's not precise because you have a relatively wide range of data points if you compare them to Group B and Group C. In fact, I would expect something like Group A to be what you would get in the real world. It's really hard to get good timing down for these kinds of experiments. It takes practice and multiple trials. After a while, people do get better at it though. Alright, and so if you take a look at Group B, I want you to think to yourself, are these accurate data points or are they precise data points? What do you think? And the answer is yeah, they're both accurate and precise. This data point, so these people were close to the true value, and they had a tight cluster of data points around that true value of 0.707. So we could describe this data as accurate and as precise. Last, let's take a look at Group C, and I want you to think about what you would say in terms of accuracy and precision for this data set over here. Okay, and so we could say that they are not accurate, but they are precise. They are tightly clustered around a central value, but that central value is not accurate. It's too high compared to the true value. Relatively speaking, if we compare it to like Group B, for instance, we can see that they are inaccurate as you compare them to Group B. Again, this would be not bad data actually in the real world. So hopefully this has been helpful. I'm going to be doing more screencasts on many topics in science. Please stick around and watch my other videos. If you like this, please give it a like. Have a great day.